Twinkle, twinkle, little star, how I wonder what you are. Up above the world so high, like a diamond in the sky. Twinkle, twinkle, little star, how I wonder what you are. I just figured I'd start off with that. That's one of my daughter's favorite songs, and she loves that video. So I thought maybe if I start this video with Twinkle, Twinkle, Little Star, that it'll make this your favorite video. So we'll go from there. We're going to be looking at reciprocal functions now. What that has to do with Twinkle, Twinkle, Little Star? Nothing, but that's okay. It's all right. So let's go. Here we have, consider the reciprocal function 1 over x. Write a function g, so we're writing g of x, such that there is a vertical dilation of factor 2, horizontal compression with factor 3, and a translation of 3, negative 2. Write the function as a single fraction and find the asymptotes. All right, so the first thing that we're going to do is we're going to go through and do each of these dilations, compressions, translations. Okay, so let's start with 1 over x. First, let's consider the vertical dilation. So if I want it to have a vertical dilation, so that's vertical, which means it has to be done on the outside of the function. If I want it to have a factor of 2, that means that the function as a whole needs to be multiplied by 2. So I'm going to multiply by 2, which is going to turn it into 2 over x. Okay, so we've got the vertical dilation done. It has a horizontal compression with factor 3. So it's being compressed horizontally with a factor of 3. Now, that means it needs to be applied directly to the x. Now, remember, on the inside of the function, now remember that anything done to x is the opposite. So if I want it to be compressed by a factor of 3, that means I need to multiply the x by 3. So we now have 2 over 3x. All right, so we have our vertical dilation, we have the horizontal compression, which means a dilation where it's being divided into 3, shortened by a factor of 3. And now we have a translation of 3 over negative 2. Now remember, this is just a column vector which is represented by xy. So this is saying that it needs to move 3 spaces in the x direction and negative 2 in the y direction. So we're going to do the y first because that's easy. We'll just subtract 2 on the outside of the function. And then we need to do our final step, which is to do the x. Now remember again, x has to be applied directly to x, and it's going to be the opposite. So instead of plus 3 to move it to the right, I need to do minus 3. Now here's the other key, is that remember if it's on the bottom, that addition subtraction has to be directly to the x. So we're going to put it in parentheses. So we're going to have x minus 3. And so there you now have g of x. It has the dilation, it has the compression, it has the horizontal translation, and it also has the vertical translation. Now it asks for it as a single fraction. So now what we need to do is we need to find a common denominator so that we can put these two pieces together as a single fraction. So we're going to go 2 over 3x minus 9. So I just distributed the 3. You don't have to do that, but I find it a little bit easier. So minus, now I need the bottom to be 3x minus 9. So if I want the bottom 3x minus 9, I need the top to have 3x plus 3x minus 9 as well. So I multiply by 3x minus 9 over 3x minus 9 to give me a common denominator, which means I now have 2 minus 6x plus 18, because this 2 will be distributed to both of those, and then the minus will be distributed to both of those, all over 3x minus 9, which in the end gives me negative 6x plus 20 over 3x minus 9. And so now I have a single fraction for g of x. There we go. So that's accomplished. Find the asymptotes. Okay, well, in order to find the asymptotes, there's a couple of ways that you can do that. One is to consider the function 1 over x. We know what that looks like. We talked about that you should be able to do this in about 5 seconds. It took me just under 5 seconds. So that's what it looks like. It usually has a horizontal asymptote at 0, y equals 0, and it usually has a horizontal asymptote at x equals 0. So one way to do this is by looking at it in terms of the transformations. That vertical asymptote will not change if I stretch it horizontally or if I stretch it vertically, right? A horizontal stretch will just stretch the things on the side, but 0 is 0. 0 stretched is still 0. Same thing with a vertical stretch. It'll make the asymptote longer, which, okay, maybe it can't do that because it already went to infinity, or shorter, which just means it goes to a lesser infinity, but it still goes to infinity. So the stretches won't really affect it. What will affect your vertical asymptote is moving it left and right. So if it has shifted to the left, or sorry, to the right 3 spaces, it's going to take that vertical asymptote and it's going to shift 3 spaces as well. So my new vertical asymptote will be at x equals 3. The horizontal asymptote was at y equals 0. Now that one is going to be affected by the up and down shift. Again, that's not affected by it shifting side to side or by stretches or compressions. The only thing that affects that is if I shift up or down, which it shifts down 2, so down 1, 2. My new asymptote will be at y equals -2. So that's one way of doing it, is thinking about it through transformations. Another way to do it is to do it mathematically. Okay, now the vertical asymptote is easy because the vertical asymptote is when x is a problem. So we just say, okay, 3x minus 9 equals 0, because the bottom of the fraction cannot be 0. So we do that, we add 9 to both sides, we end up with 3x equals 9. So again, we have x equals 3. So that's a problem. When x equals 3, the bottom is 0, so that is my vertical asymptote. Now, the horizontal asymptote is a little bit different. The horizontal asymptote is actually much more helpful from this first format that we had up here. Now, the reason for that is because in our drawing here, you'll notice that the horizontal asymptote is what you get closer to when x gets really, really big or x gets really, really small, as in a big negative number. Okay? So what we need to do is just make x a really, really big number. So if x is really, really big, that's going to make the bottom of our fraction really, really big. And 2 divided by a really, really, really big number is going to be really close to 0. So what we end up with here is 0 minus 2. And 0 minus 2, of course, is -2, which means that our horizontal asymptote is at y equals -2. Now, there's actually a third way that you can go about it, and that's actually by using a limit. Now, for a limit, these pieces are not going to be as important because we know that as x gets really, really big, x is going to be infinity. So this is going to be -6 times infinity. Adding 20 to that is not going to make a difference. Okay, 3x going to infinity, also the -9 not going to be important. So really all I need to do is look at the -6 over 3, and you'll notice that -6 divided by 3 is, again, -2. So we've come up with several ways of finding our horizontal and vertical asymptotes. As I go through the other examples, I'm not going to do all those ways again, but you're welcome to use any of those methods to try to find your asymptotes. All right, so here's the next one. Oh, that one is not showing up, so we're just going to fix it up. So 2x minus 6 over x plus 1. All right, so we're going to find the asymptotes and transformations from 1 over x. So the easiest thing, if you remember what we were doing here, is that when it was in this format right here, when it looked like this, it was really easy for me to see what's done on the outside, what's done on the inside, what it's been multiplied by, and what has been done to the x on the bottom. And so I'm going to actually try to take what we have and rewrite it in this format right here. Now there's a couple of ways to do that. Again, you have different options. You may have learned in a previous math class that you can take 2x minus 6 and you can divide it by x plus 1. Now if you do that, you go x goes into 2 times, so, and actually you probably learned to put the 2 right there because there's 2 terms, so right there, so 2 times x is 2x, 2 times 1 is plus 2. Now as in long division, you're going to subtract those, the x's cancel out, -6 minus 2 is -8. So when you divide those, you end up with 2, and then you've got, a remainder of 8 over x plus 1, because the 8 really then should be divided by x plus 1 again, but that's going to keep happening, so we may as well just say, okay, well, negative 8 divided by x plus 1 is negative 8 over x plus 1. So that's one way to get it into the desired format. Now, another way that you can do this is that we can work with that 2x minus 6 algebraically, okay? And so what we're going to do is we're going to make this 2x look like the x plus 1. And so what I'm going to do is change it so that it's 2 times x plus 1. Now the 2x, 2 times x, was already there. So what I've actually added is I've gone 2 times 1. So I've added 2. So there was a 6. Since I've added 2 here, I need to subtract another 2 to keep it balanced. Still over x plus 1. Now, at this point, I now have 2 times x plus 1 minus 8 over x plus 1. And I can separate this now into two fractions, which is 2 times x plus 1 over x plus 1 minus 8 over x plus 1. Note that the x plus 1's cancel out, leaving us with the same thing as before, 2 minus 8 over x plus 1. So if you've learned the long division, this is probably a good way to do it, because it looks like it's a little bit faster and easier. If you haven't learned that, you can do the same thing just by getting that bottom term to cancel out for one of our pieces up here. Alright, so either way, we end up with this. Okay, so we need asymptotes, we need transformations. So let's do asymptotes first. So horizontal and vertical. Now remember, the vertical asymptote comes when the bottom is equal to 0. So x plus 1 equals 0. So therefore x equals negative 1. So that is my vertical asymptote. And then the horizontal asymptote comes, again, remember, when x gets really, really big. So when x gets really, really big, I'm going to have 8 divided by that. 8 divided by a really, really big number is going to get really close to 0. So it's going to be 2 minus 0. So therefore, my horizontal asymptote is at y equals 2. So there we go. We've got our asymptotes. Now let's talk about our transformations. Now part of this is going to be really easy because we already have part of it. We have a vertical translation of 2. Okay, or positive 2. Vertical translation, you could say up, would be safer, of 2. We know that because there's been a 2 added on the outside. Remember, it just started as 1 over x, so there's being a 2 added on the outside somewhere. We also know that the horizontal asymptote used to be at 0, and now it's up at 2, so it's moved up 2. It's got a horizontal translation left of 1. And it's better to say left of 1 than it is to say a horizontal translation of negative 1, because if you say left, then it's very clear that you understand which way it's going. If you say negative 1, it kind of sounds like you're not sure which way it's supposed to go, but you see a negative 1, so you're just going to write it down. So horizontal translation left of 1. And so that's covered by the vertical asymptote. It's also covered by the fact that I'm adding 1 to x, which means do the opposite, shift to the left. Okay? And then I've got an 8 on the top, which means that my 1 over x has been multiplied by 8. So I've got a vertical, right, because that's not being applied inside the function. It's on the outside. It's being applied on the outside. So vertical stretch factor of 8. And then we have one last thing. There's a negative on the outside. Now remember, a negative on the outside will be a vertical flip or a reflection over the x-axis. So reflection over x-axis. All right? Now, I want to go over one last idea. This will probably take another 2-3 minutes, but we do want to talk about this one last idea before we give up and go home. So I want to talk about how to sketch a reciprocal function given the original. Okay, so here's my original function. This is f of x, and this is a separate question here. I want to sketch 1 over f of x. Now, one of the best things to do is to recognize that if f of x is 0, I'm dividing by 0, so there's a horizontal asymptote. So the first thing I'm going to look at is when f of x is 0. So that's right here. So my reciprocal function there should have a vertical asymptote at -2, because at -2, f of x is 0. If I divide by 0, I'm going to get an asymptote. Okay, so I'm going to end up having 4 asymptotes here because there's 4 places where f of x is 0. Alright, now I need to figure out what's happening in between those. Now remember, as you get closer to an asymptote, it should be either shooting up or shooting down. And so that's what we're going to consider next, is we're going to say, okay, well, here, my value is getting really, really close to 0. So if I take 1 and divide it by a really small number, what do I get? Well, I should get a really big number. And so it's going to look something like this. Okay. As it gets farther and farther out, as it gets bigger and bigger, I expect that it should get closer and closer to 0. All right. Now, in the middle. So down here, it's really close to 0, but negative. All right. So that means it's going to be here. Now, notice that my minimum is a little bit below -2. So if I go 1 divided by -2, I get about -1/2, which means that -1/2 is my turning point, so about right there, and then it goes back to 0, which means I'm going back down to -infinity. All right, same thing will happen here. Here, f of x is 4, so 1 over 4 would be 1/4. So this time I'm going to get a little closer to the x-axis. Should be alternating unless there's a reason for it to do otherwise. Okay. Same thing here, so it goes down to just over the 1/2 mark, so like this, and then again from the top, and as it gets bigger, I should get closer and closer and closer to 0. And there you go. So that green line is the graph of 1 over f of x. Let's see if you can do it for this one. All right, I'm going to give you a minute to draw the graph. The best way to do this is to draw the graph first and then make your interpretations from there. So I'm going to pause it. You go ahead and work. You pause the video, and then we'll go from there. All right, so I've got my function drawn here. Note that I got for my x-intercepts plus or minus 1 over root 2, which I've got there. My y-intercept was 1, which also happened to be my vertex. So I've got my original function. Now, if I want 1 over f of x, again, I'm going to look for the zeros because those are going to be my asymptotes, because I'm going to be dividing by 0 there. So there we go. There's my asymptotes. Now I'm ready to draw the function. Again, on this side, I'm going from a really big number. So if I do 1 divided by a really big number, it's probably going to be really close to 0. As I get closer and closer to this point, f of x gets closer and closer to 0. As it gets really close to 0, it's going to tend to infinity. So something like that. Should pick up on the other side. Now notice here that f of x is -1. 1 divided by -1 is -1, which means that should be my maximum there before it starts going down again. And then I should get an exact repetition because it is symmetric. So something like this on the other side. So there you go. You've managed to draw a reciprocal function. They look pretty cool if you ask me. Anyway, that's the video. Ciao.